We relate to up more than down. It's easier for it to jump than to fall into a hole. And then, so now this is our first quadrant that we ever learn, and then we go around counterclockwise. So what are the coordinates? Hint, same numbers, change some signs. So I wrote the same numbers, minus 7, 1, minus 2, 3, minus 7, 6. I wrote the 7, 1, 2, 3, 7, 6. And the other point is all points in the third quadrant are negative x. So it has to be negative 7, negative 1, negative 2, negative 3, negative 7, negative 6. You can go ahead and plot those, and you'll be able to see that reflection. Example 2 is now reflecting across a horizontal line, which we just did, but this horizontal line is not going to just change the signs. Example 1, we reflected upon the y-axis, which was a vertical line. Our pre-image was xy. Our reflection was negative xy. Then on the second example, when you went to a double prime, b double prime, c double prime, we reflected upon the x-axis, was the horizontal line, which means if the pre-image is xy, then our reflected image is x negative y. Reflection across the y-axis, we changed the x coefficient from positive to negative, and the pre-image to the reflected image across the horizontal line is x, and we changed the y. So if u is 2, 6, u prime is 2, negative 6. So let's look up at the example in the book. Here we have u being over 2 and up 6. Now we can see that they want to reflect upon y equals 4. Well, how far away is 2, 6 from y equals 4? It is 1 square, or 2 points. So here we have 2 away, which means that its reflected value will be 2 points this way. Well, how can we write an equation or have a formula for figuring that out? Well, let's first remember that to reflect across this axis down here, the x-axis, it would be 2 minus 6. So let's start with that, and we will come back. It would be 2 minus 6. But we saw that it needed to be 2, 2. That's where we see that it's going to be. Well, if we say minus 6, we're going to shift it plus 8. So each point will keep its same x coordinate, no change, and the second one will be the negative of the pre-image plus 8. So please pause and write down the coordinates for S, T, U, and V, and S prime, T prime, U prime, and V prime. Example 3. This is reflection across a line, a special line, a very nice line, y equals x. Get familiar with this line. It is a fun line. It happens to be 45 degrees. You will recall that a line perpendicular to another line will have its slope, will be at opposite slope. So if we have y equals x, the opposite slope, the perpendicular slope, is y equals negative x. So each point xy, the formula for this, when it is reflected across the line y equals x, becomes yx. So the transformation of xy becomes yx. All other reflections were made with each point's perpendicular distance to the reflective line, which was easy with the x and y axis. The reflected image points located equiperpendicular distance away also. For example, sketched out here, the point 1, 2. We go perpendicular down to the axis and 2 more further down. So a 1, 2 changed to 1, negative 2. In this case, we have the letters J, K, L, and M. The transformation of minus 3, 5 becomes 5 minus 3. The reflection upon y equals x for k being 0, 8 becomes k prime is 8, 0. Transformation of point L, 3, 5 across the line y equals x gives L prime of 5, 3. And the transformation of M, which is at 0, 1, across the y equals x line is M prime, which is 1, 0. Go ahead and map those out on your graph paper. Now, example 4 in the book is a little different. I'm bringing this in to show a shape of PA and a triangle over it. In the textbook, they drew a varied shape, but this reminded me of writing my name in cursive, folding the paper and drawing the reflection. We actually did this with crayon so that the original image could transfer better as we rubbed on the back. Next, you turn the paper 90 degrees so point A is at the top. And then you have an interesting new picture, if you will, that you can color in many different shapes. You can turn it into an antenna or eyeglasses or anything that you see in it. And that is an example of reflecting upon another horizontal line. The example is, in the book, I am going to zoom into the book, a lathe. If you aren't sure what a lathe is, a lathe takes a piece of wood, which is usually round, like a dowel, thick, like a leg of a chair, and as you move a knife along or a file, a rasp, you can start going along it as the wood turns toward around and around this way. So this way it says I'm going to turn the pen. It is traveling very fast. It will make a circular shape like this. Please look around your house. Please look around your house for your chairs. See if any of the dowels have been cut out on a lathe so that they have the same shape all the way around no matter which way you turn it. And on the example in your book for the practice, you can go ahead and graph this out on your graph paper and draw your reflection upon x equals 4, and you will show that it shows an optical illusion. Have fun with that.